Hello everyone, in this section we are going to talk about significant figures. Significant figures are an important part of scientific and mathematical calculations. Under this topic we will discuss what is a significant figures, rules for identifying significant figures and determining the number of significant figures in a given value, and how to approximate a measurement to a given number of significant figures, and also we'll do some calculations with significant figures. The term significant figures refers to the number of important single digits 0 to 9 in an expression of a measurement. They are the number of digits in a value that contributes to the degree of accuracy of the value. Let's take this example. Here we have a candy cane and we are measuring the length of the candy cane using 2 rulers. When we use the first ruler, we can read the length as 4 centimeters. And when we use the second ruler, we can measure 4.2 centimeters as the length. So we are measuring the same candy cane, but we got 2 readings from the 2 rulers. When we consider the accuracy of these 2 numbers, we can say the measurement 2 is more accurate than the first one. Why is that? Because we have measured up to 2 significant figures. So we have 1 and 2 significant figures in the second reading. But compared to that, we have only 1 significant figure in the first reading. So we say the second reading is more accurate than the first reading because it has more significant figures. Let's see how to find the number of significant figures in a given value. We'll take some examples and we'll discuss the rules applied when we are finding the number of significant figures in a given value. Let's take a number which we don't have any zeros. So for example, 4,237. In this number, we don't have any zeros, so all the numbers are significant. So here we have 4 significant figures. Let's take a number with zeros. When we have a number with zeros, we first need to check where the zero is. If the zero is at the beginning, we say zero is not significant. For example, if we take 0.065, here we have 2 zeros at the beginning and we don't count zeros as significant. When we are counting the number of significant figures, we start counting from the left-hand side, and it should be a non-zero digit. So this is not a significant figure. The second zero also not a significant figure. Third one is a non-zero digit. So this is my first significant figure and this is the second one. So here in this reading, I have 2 significant figures. Let's take a number where we have 0 at the middle. For example, we take 6,503. 0 is at the middle, so 0 is significant. We start counting the number of significant figures from the left-hand side, non-zero digit. So first one, second significant figure, third one, and the fourth one. So in this reading, we have 4 significant figures. Now when the 0 is at the end, first we need to check whether the 0 it's a decimal number or whether the number is a non-decimal number. If the number is a decimal number, for example, 52.30, we count 0 as a significant figure. So in this number, we have 4 significant figures because we count 0 as a significant figure. Let's take a number where we have zeros at the end, but which is non-decimal. So here if we take 5,200, we have 2 zeros at the end, but it is not a decimal number, so we don't count zeros as significant. So we are counting from the first non-zero digit at the left, 1 and 2. We don't count these ones as significant, so we have 2 significant figures in this figure. Let's take this example. On 9th August 2014, the Australian Bureau of Statistics population clock stated that the population of Australia was 23,573,832. But a friend of ours said that the population of Australia on the same day was 23,600,000. Both the readings are right, but when we compare the accuracy of the two readings, the first one is more accurate because it has measured up to 8 significant figures. The second reading is comparatively less accurate because it has measured only up to 3 decimals. Let's take few examples and try to round off to a given number of significant figures. Here we have 45,573,832. And we need to round off this value to 3 significant figures. We'll first count number of significant figures here, starting from the first non-zero digit. So this is my first significant figure, second one, and the third one. So I need to round off at this point. After that, I have 7, which is more than 5. So I add 1 to this 5. So when I am adding 1 to that 5, my number will be 45,600,000. So we have only 3 significant figures in this number. See, 1, 2, and 3. When the zeros are at the end and when it is not a decimal number, we don't count them as significant. So we have rounded off this number to 3 significant figures. Let's take another example. Here we have 0.058387, and we need to round off this number to 2 significant figures. We'll start counting this number of significant figures from the first non-zero digit at the left. So this is not a significant figure. This is not a significant figure. We start from here, and this is the second one. So we have to round off at this point. After this, we have a 3, which is less than a 5, so we don't add anything to 8. So I just write as 0.058. So I have only 2 significant figures. See here, if I put zeros at the end, what will happen? Then we have more than 2 significant figures. So we don't put zeros at the end. So our number, when we round off to 2 significant figures, that will become 0.058. Let's do some calculations with significant figures. We'll start with multiplication and division. Here we need to first find out the number with the fewer significant figures. Let's take this example. And here I have 3 numbers. The first number is with 3 significant figures. The second number is with 2 significant figures. And the third number is with 4 significant figures. So the fewer number with the fewer significant figures is this one. So I have to have the same number of significant figures in my answer, which is 2. Let's take another example. Here I have 2 numbers to multiply. In the first number, I have 1, 2, 3, 4, 5, 6 significant figures. And in the second number, I have only 3 significant figures. So the number with the smallest significant figure is this one. So my answer also should have 3 significant figures. In addition and subtraction, answer determines by the number with the smallest uncertainty. That is the fewest digit to the right of the decimal point. Here in this example, we have 3 numbers. In the first number, we have 3 decimals. In the second number, we have 1 decimal, and in the third number, we have 2 decimals. When we compare the number of decimals in these 3 numbers, the number with the smallest uncertainty is the second one, which has just 1 decimal point. So I need to keep the same number of decimals in my answer. Here, my answer is 153.613. In this answer, I need to have only one decimal point. So I don't write the other decimals. My answer now will be 153.6.